Hi, I'm Neil Feit of the Philosophy Department at SUNY Fredonia. I'm going to do some proofs in this video in statement logic using the rules of conditional proof and reductio ad absurdum. Reductio ad absurdum is sometimes called indirect proof, sometimes called proof by contradiction, and these are two rules in our proof method which enable us to make assumptions and make our system complete and oftentimes make our proofs easier to do. Okay, I'm going to do a conditional proof first. I'm going to select, and this video, by the way, is going to supplement these two sections in the Power of Logic textbook 8.4 and 8.5. I'm going to choose an 8.4a exercise, and I'm going to do number 5 here pretty quickly. Okay. So this premise, the argument rather, has only one premise, so I'm going to start with number 2. And I'm looking at the argument. I see that the conclusion is a conditional, and I should think to myself, oh, I should want to do a conditional proof. So using the program, I'm actually going to go to the left of the number and hit the shift of the key that's above the enter key to get a horizontal line here. Okay. So basically I'm going to make an assumption, E. Okay. And I'm going to assume that. Why am I assuming E? Well, because it's the if, the antecedent of a conditional that I want to prove. I'm looking at the conclusion, and I'm assuming the antecedent of what I ultimately want to prove. And that's an assumption for CP. Okay. Now I still need to indicate to the program that I'm in the scope of an assumption, in a box. Okay, so I'm going to put that line before the line number 3. Now I want to prove K, because that's the consequent, the then part of the conclusion. It's really easy now. I could just take E and use the rule of addition to get H or E. Okay. That comes from line 2. Line 3 follows from line 2 and line 2 alone by the addition rule. Okay. And I'm still in the scope of my assumption here, so in the box still. Now line 3 and line 1 have modus ponens form to give me K. So that's a 1, 3 modus ponens. I don't need capitals on the rule. Okay. At this point, if we were doing this, I'm going to go to blue color here. If we were doing this on paper or you're looking at the proof in the book, we would kind of have a box here. Okay. But under the letter K here, we would end the box since that's the consequent of the conditional here. So the logic here is something like this. I've assumed E on line 2, and I've showed that K follows from E, okay, given the premise of the argument. Okay, so basically, I've in essence proved if E then K, and that's what the rule of conditional proof lets us show. So line 5 no longer has that vertical bar next to it, and we've just basically proved here if E then K. Okay, 2, 3, and 4 are true only on the assumption of E, but line 5 is true flat out. Just given the premise, line 5 follows E then K. So that's 2 through 4 conditional proof, and if I check the proof, hopefully that's going to be correct. Congratulations is a good sign. Okay. If we did not have conditional proof here, we would basically have to use material implication on this premise. We'd have to make it if either not H or E or K, and we would have to do something with that. We'd kind of have to then use De Morgan's on this and do blah 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 until we could somehow get to our conclusion, probably via not E or K, which is equivalent to the conclusion, by material implication. So I invite you to do this proof without conditional proof. Conditional proof makes it a lot easier. Okay, I'm going to select another from exercise 8.4a here, except the one that I select, I'm actually not going to do the proof. I'm just going to kind of sketch out how it would look. I'm going to go down to number 23. Okay. Okay. Again, I'm not going to do the proof here, but notice here what we want to prove is a biconditional statement. Okay. A good way to do proofs of this sort is to do as follows. Okay. Do a conditional proof, assume not B, do some logic, and derive not A. Okay. If you do that, you get not B, then not A by conditional proof. Okay, and that's going to be pretty easy here because if you assume not B here with line 1, it's going to be pretty easy to get not A. Just use the top version of material equivalence and you'll should see what to do. I'm going to continue over here. Okay, now we have not B then not A. It's not in a box, so it's available to use to get to our main conclusion. And then what we simply do is make another assumption in the same proof. We just assume not A. We want to go in the right to left direction. Not A, do a little bit of logic and get not B. We could still use premise 1, and that's what we would be using to get not B here. And we would get not A, then not B. Okay, so basically we're trying to get the biconditional in the left to right direction, right? Left to right direction. And now this is the right to left direction, the right to left direction. Okay, and what I could then do is take this, which is not in a box so I can use it, and take this way down in the proof and use conjunction, conjoin them together, and then use the material equivalence rule to get this. Okay, so that's conditional proof is a good way to prove biconditionals. Essentially, you do two conditional proofs within the same proof, not nested within each other, but one following the other. Okay, that's a good way to do that argument with conditional proof. I leave the proof to you as a viewer. You could pause and do it if you want, but I'm going to go on. I'm actually going to try to do a proof here, more from chapter 8. There's a good thing down here. It's a create your own proof exercise. And basically, if you notice here, for example, there are English arguments in the textbook exercises where you have to symbolize them and prove validity. And some of them have answers in the answer key in the hard copy of the textbook, and that's a good thing to do. You could check your answers there. But a lot of them don't, and what you can do is try them out here. Okay, I'm actually not going to do one of those. I'm just going to enter my own argument here. Okay, so let's do a conditional proof, and I invite you to pause it after I kind of key in the premises and try to do the argument. A then B or C is going to be my first premise. Okay, my second one is going to be E then C or P. I'm going to have one more premise, not C. And for a therefore, I'm going to use a colon period. That'll give me a therefore. My conclusion here is going to have sort of a compound antecedent. It's going to be neither B nor P, not parenthesis B or P. And therefore, it's also going to have a compound antecedent, consequent rather, not A or E, neither A nor E. Okay? Okay, so here's my thinking. I'm looking at this argument. I notice that the conclusion is a conditional. Okay, oh, I should do conditional proof. So I should make an assumption. Okay, what should I assume? Well, I should assume the antecedent of the conditional that I want to prove, not B or P. Okay, so what I'm doing is I'm assuming this for CP. Oops. All right, so I'm still within the scope of that assumption. Okay, line 4 is a negated disjunction. That should immediately make you think of De Morgan's law, not B and not P. If it doesn't, you've got some work to do. Okay, that's a 4 De Morgan's. Dem. Okay. Should I simplify line 5? Yeah, I should. Should I simplify both conjuncts? Yeah, I probably should, because I'm looking up to, premise 1, I see B, premise 2, I see P. I should probably get those both out there. Even if I don't use them both, which I'm going to, it would still not be such a big deal. So not B is a 5 simp. Not P. Also a 5 simp. Again, the dot's the main operator of line 5. I could use simplification. Okay, alrighty. What am I going to do here? Let me take a moment here. Having assumed this for conditional proof, I want to derive now the consequent here. Okay, and I can make a little bit of a wish list here. So obviously I want to get what I just put in that green box. Well, if you're thinking about De Morgan's, which you should here, that's logically equivalent to not A and not E. That's a lame dot that I just made, but that's a dot. Okay, so if I could get not A by itself and not E by itself, that would be very helpful here. And I see here that A and E are both the antecedents of 1 and 2, so that should make me think of trying to use a modus tollens with line 1 and another modus tollens with line 2 to get not A and to get not E. Okay, I'm going to, you could pause this if you want to think about it, and I'm going to kind of erase my little wish list work here and get on with the proof. Okay, so I could get not A out of line 1 if I had neither B nor C, not B or C. Well, I have that. I have not B from line 6, and conjunction, I have not C with line 3. So that's a 3, 6 conjunction. Okay, and basically what I could do is use De Morgan's to get that into the form of the negation of the consequent of line 1, not B or C. Okay, so that's in 8 De Morgan's. Oops. So I'm to line 10 here. Now lines 1 and 9 have modus tollens form to give me not A. 1, 9 modus tollens. Still in the box here. Okay. I'm basically going to do the same thing for line 2. I see not C up there on line 3. Not C. And I see not P on line 7. So that looks like it's a 3-7 conjunction. And I'm going to just use De Morgan's again. I make that not parenthesis C or P. That is 11 De Morgan's. Still in the assumption there. Okay. Why did I do all that? Well, line 12 is now the negation of the then part, the consequent of line 2, so I could get not E by modus tollens of 2 and 12. Okay. And basically I'm going to now follow that wish list sort of towards the conclusion here. Okay. I have my not A up on line 10. I have my not E. Line 13, that's conjunction of 10, 13. Why did I do that? Well, I was thinking about that before when I was having green writing on the screen. That becomes neither A nor E by De Morgan's. That's a 14 De Morgan's. And notice now line 15 is the consequent of what I want to prove. So I'm not going to put a vertical line there. If I were doing this proof on paper, I would have a box subproof kind of going down like this, and I would end it here. Okay, because I assumed the if of the conclusion. I've reached the then of the conclusion. So basically, line 16 is going to be the last line of this proof. Okay, so if line 4, if not B or P, then line 15, not A or E. Okay, that is or in this case 4 all the way through 15 conditional proof. Okay, I'm hoping that's going to be right if I check it. And it does say congratulations. It gives me a nice message that this proof is correct. Given those premises that I entered and the conclusion that I entered, this is a correct proof of the conclusion. What I want to do here is hopefully pretty quickly I guess I'll go back. Okay, I'm going to go do a couple of Reductio Ad Absurdum proofs. I'm going to go 8.5. Let's do this simple one here. Okay. Actually, maybe not so simple, but not bad at all. Okay, this is in the textbook, exercise 8.5, a number 5. It only has one premise. Okay. Gee, only one premise, not much to work with. In fact, in the instructions here, we're told to use RAA. So I'm going to go back and make an assumption. Okay. My conclusion is M. What do I want to assume? Well, the opposite. Do the opposite, not M. Okay, that's assume for RAA. Okay. That's really about the only thing you could do here, unless you want to get fancy with equivalence rules, which is possible. Okay. The assumption here gives us some help because now 1 and 2 do instantiate a simple implicational rule, modus tollens. So that gives us not M then L. Okay, so that's a 1, 2 modus tollens. Okay. Keep in mind when you make an assumption for RAA, okay, you want to derive a contradiction. That's the only way you can discharge an assumption for RAA is to get a contradiction. And it's the only way, given that you made an assumption for RAA, it's the only way that you're going to be able to finish the proof. Okay? What I have to do here is basically I have to take this M then L and use material implication. I have to make it not M or L. Okay? That's going to be one of our most useful equivalence rules. So that line 4 comes from 3 by the material implication rule. But still, it's not going to be such a bad proof because now I could use De Morgan's on line 4, make it not M and not L for De Morgan's. Okay, still in the scope of the assumption. If I take not M and simplify that from line 5, a 5 simp, okay. Okay. I'm almost done. Some of you watching this video might use double negation on line 6 and make it M, and then look up to line 2 and get an M and not M contradiction, and that's perfectly correct. It's perfectly fine. But really, we don't really need to do that. I could just take my not M from line 2 and my not M from line 6 and do a 2-6 conjunction. Okay? And line 7 is a contradiction. Oops. Not M is Q. Not M is not Q. And that's a perfectly good contradiction. So really, I'm done here. And I've assumed not M. That led to a contradiction. So therefore, M must be true. That's a 2 through 7 in this case. RAA. So if I check that, okay. Not such a bad proof at all. Maybe this was the trickiest part, but we have an easy way to break up the negated conditional using the material implication rule in our proof method for statement logic. Okay, I'm going to do one more, hopefully pretty quick to finish this off. Let's go down to number 18. Okay. Oop. Okay. Okay. Notice here I want to prove a conjunction. Okay. What do I want to assume for RAA? I am going to make an assumption here. Okay. I think I want to prove not C, and I want to prove T, and conjoin them together, and then I'll be done. Okay. How do I want to prove not C? Well, I think I'm going to use RAA just to prove not C. I'm going to assume the opposite of that. I'm going to assume C. Okay. So that's actually there's other ways to prove this argument. I think that's going to be the best here. Okay. You could make an assumption, any assumption to prove anything, but why did I just assume C to prove not C? Well, I look up at line 1 and I see that the antecedent there is C. So now I could get D then H. Oops. Then H. That's a 1 for modus ponens. Okay. Okay. I have D in line 2, which I could simplify out. 2simp. Okay, so 5 and 6 modus ponens, I could get H. 5 comma 6 modus ponens. 8. Okay. Again, having made an assumption for RAA, I don't know if the computer is going to snag me on this, but for RAA. I want to get a contradiction, so it's important to keep in mind you want to derive a contradiction. If I look up at premise 2 again, I could simplify not H right from there. That's a 2simp. And that's going to be my contradiction. So, oops, line 9. I have H from line 7 and not H from line 9. 7 comma 9 conjunction. And I'm not going to have a vertical bar there because I'm not in a box anymore. I'm now in a position to use RAA, because the idea is if C is true on line 4, then a contradiction is true, H and not H. But a contradiction can't be true, so C can't be true, not C. So that's going to be a 4 through 9 RAA. Okay. But I'm not done yet, because I want to prove more than not C. Okay. It's important to note here, that at this point in the proof, all these lines in the box here, I can't use them anymore to justify subsequent lines. They're only true only on the assumption that C. But I've discharged that assumption. So I can't use those lines anymore. They don't follow from the premises. They really don't. They follow only on the assumption that C is true, which it's not, because we've proved not C on line 10. So I can't use 4, 5, 6, 7, 8, or 9 to justify any steps anymore. But I can get T, in other words, the other part of what I prove, using just what I've proved so far. Okay. Notice what I can do again is I could get not H again from a 2simp. Now I already did that on line 8, and I'm not allowed to use line 8, so I'm going to do it again. Maybe I should have done that up on line 4, even before I made an assumption for RAA. That would have saved a step in this proof, but I really wasn't thinking so clearly ahead at this point. But now line 11 rather does follow from a premise of the argument. So now line 3 is a disjunction H or T. Line 11 is not H. So by disjunctive syllogism of 3 and 11, I get T. Okay. So now I'm pretty close to finishing this proof. Not C is something that I can use because I proved that on line 10, and T is something that I can use because I proved that. So that's a, a 10 comma 12 conjunction. Okay, so here's a proof where we used RAA, but we didn't use it on the main conclusion of the argument. We just used it to prove part of what we wanted to prove, and that's perfectly legitimate. Okay, so this, oops, okay. The justification of line 9 is, I do that sometimes. Sometimes I say that a line is justified by itself. Line 9 really comes from 7 and 8 conjunction. Check that. Okay, now it's right. Okay, so I hope some of these proofs were helpful to you.